Okay, we're going to take a look at another kind of loop that we can use in our coding. This is another fundamental structure for programming your Arduino, the for loop. So it's going to look a little bit like the while loop and a little bit like an if-then statement, but have a slightly different structure. So let's go ahead and get started. The first thing we're going to do is define a counter that we'll use in our for statement. So I've called that for counter up here and set it equal to 0. We are going to be using our serial monitor, so I'll open that up with the code. And the first thing it's going to do is ask us to enter a positive integer. We've got this while statement here. If you don't know what that means, go ahead and watch the video on while loops. It'll explain that what's going on here is it is telling us that telling the serial monitor not to do anything, not to display anything. Don't go read any further code or anything until something has been entered there. So now we enter a value into our serial monitor and we read it into our for counter. So it was equal to 0. It's now equal to whatever value we put in. This semicolon's in kind of an odd spot, so let's fix that. All right, and now what we're going to do is we're going to introduce another integer called I right here. We define it as an I, and we start that off at 0. And we say for that integer, for when it's less, for values of I that are less than or equal to for counter, the number we just read into it. And this last step is telling the for loop to increment I when you get to the end of the loop. We could also put that within the loop, but you can use this structure here to tell it what you want it to do. Serial print the statement I equals, then serial print the value of I, and then exit out of the for loop once that's done. So it's going to repeat this. Remember, again, this is what happens when you get to the end of the code. So it's going to increment itself, go back up here, and see if I is still less than for counter. If it is, print it out again, increment, go back up to the top. So actually, let's move this. It'll be a little bit easier to see. We put this at the end exactly how that's happening. So again, we get a value. We compare I to it. If it's smaller, we print the value of I, increment I, start the loop over. We keep doing that until we get to a point where I is no longer less than or equal to the value we read in, at which case we look for a new value of I and print a blank line. So let's take a look at how this functions here. Okay, so we'll enter our positive integer. Pick a smaller one actually. Let's look at 7 and see what happens. Notice it prints out all the values up to 7. Enter another one. Let's do 32, slightly bigger number. Again, we've got this whole list of all of the integers between 0 and 32. So it keeps iterating through that for loop until it hits this value that we entered in, and then it stops. Now, what happens if we choose a number smaller than 0? It asks us for a new integer. The reason why is that we started off with I being 0, and then we're making I bigger. So since the value we chose is always smaller than 0, this statement is never true. And so we can't enter the for loop. We just go to the end. If we put in 0 itself, let's see what happens there. We just get I equals 0. It goes through the loop one time. All right, now, I said earlier we could put this up here in the instructions. So let's see if that changes the behavior any. All right, so enter a positive integer. Looks like it's 6. It behaves exactly the same way. 9 does that. A negative number just asks us for a new one. All right, now let's see what happens if we leave this out. Just don't include that statement at all. All right, just like before. When we enter a negative integer, it just asks us for a new one. When we enter a positive integer, however, it gets stuck in an infinite loop. And the reason why is that I started this for loop with a value of 0, which was in fact less than the value of 6 that we entered. So this was true. It printed out I, and then it never changed the value of I. So it stayed in the loop, checking again. I was still 0, which was still less than this. So it keeps doing this because we never change I, which means it never gets larger than our for counter. So if you ever see behavior like this in code you've written, you might want to check to make sure that you've properly incremented your counter inside of a loop to make sure that it will eventually force a false statement here, which allows it to exit the loop. That's it for loops.